بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the solution of the final exam of term 212 first semester, May 2022. First question, let f of x equals to this function polynomial. Find the absolute maximum and minimum of this function on the interval from -3 to 2. To find the absolute maximum and minimum on an closed interval, we find the derivative of the function, which is 6x squared minus 6x minus 36. And then we find the critical numbers. And to find the critical numbers, we put the derivative equals to 0, and we solve this equation. We find the two solutions. If you use the calculator, you can use mod 5(3) here to solve, or you can use the quadratic formula, or you can easy factor. If you divide by 6, you will have x squared minus x minus 6 equals to 0, and you can factor easily. X minus 3 times x plus 2 is 0. -3 plus 2x is -6. So either x is 3 or x is -2. These are the two critical numbers of the function. They belong to the domain of the function. Of course, the function is a polynomial, so the domain is all real numbers. But we need the critical numbers inside this interval from -3 to 2. So 3 is not included. So we choose the critical numbers on the interval, and we put these values, the end points of the interval, -3, 2, and we choose the critical number inside this interval, which is -2. 3 does not belong to this interval. And now we find f of x, okay? We replace x here by -3. So we use the calculator. 2 times -3 to the power 3 minus 3 times -3 to the power 2 minus 36 times -3. And we will find that the answer is 27, while f of 2 would be -68, and f of -2 is 44. Now, the absolute maximum is the greatest number here, which is 44. So we can say that absolute maximum is f of -2, which is 44, and the absolute minimum is f of 2, which is -68, because it is the smallest number. Find the intervals of concavity and the inflection. This is inflection points, okay? Inflection points of the function. Well, this is f of x, the function, same function, question about the same function. To find intervals of concavity and inflection points, we need to find f double prime, the second derivative of the function. We found the first derivative here, so let us find the second derivative. 2 times 6, 12. 12x minus 6, that's the second derivative. Now to find, we need to find the zeros of the second derivative, so we put it equals to 0. And we solve. 12x would be equal to 6, then x would be 6 over 12, or half. So this is the number that makes f double prime 0. And we need now to check the signs of f double prime. When f double prime is positive, f will be concave up. When f double prime is negative, f would be concave down. So if we choose a number less than half, Of course, the domain is from negative infinity to infinity. 0, for example, 0, if double prime would be negative 6. So it's negative here, positive here. So concave down here, concave up here. So I can find intervals of concavity. I can say concave up from half to infinity, concave down from negative infinity to half, and I have an inflection point with coordinates. Half is the x coordinate and the y coordinate is f of half. So you can go to f here if you like and replace x by half and find the answer, or you just write it like this: half and f of half. Verify that the function f of x, we are still talking about the same function, okay, satisfies the hypothesis of the mean value theorem on the interval 1, 4. If you remember the hypothesis of the mean value theorem, we need the function to be continuous on this domain. So f is a polynomial. Domain of f, we said all real numbers because it's a polynomial. So f is continuous on its domain, and especially it's continuous on the closed interval 1 and 4. This is the first hypothesis. The second hypothesis, we found f prime here, and f prime is also a polynomial, and the domain of f prime is also all real numbers. So f is differentiable, especially on the open interval 1 and 4. So by mean value theorem, there exists C in the interval, in the open interval 1, 4, such that f prime of C equals f of B, which is 4, minus f of A, which is 1 over 4 minus 1. Now, if you calculate f of 4, so you go to this function and replace f by 4, you will find that it is negative 64. And f of 1 is 2 minus 3 minus 1 minus 37. Four minus 1 is 3. If you divide negative 64 plus 37 over 3, you get negative 9. So f prime of C, what is f prime of C? This is f prime of x here. So f prime of C would be 6c squared minus 6c. So 6c squared minus 6c minus 36. This is f prime of C. Would be equal to this number, which is negative 9. So now solve this equation and find the solution. So we have 6c squared minus 6c minus 36 plus 9 is negative 27. Again, you can use the calculator to find the solutions of this derivative, of this equation. Mod 5, 3. If you put 6, you can divide by 3 if you like. Negative 6, negative 27. The solutions are about 2.7. It is 1 plus the solutions C is equal to 1 plus or minus square root of 19 over 2. Okay. So the first number is approximately 2.7. And the second number is approximately negative 1.7. 2.7 belongs to the open interval 1, 4. Negative 1.7 does not belong to the open interval 1, 4. So C, find all numbers C that satisfy the conclusion. The number that satisfies the conclusion of the mean value theorem is this number, or approximately 2.7. evaluate the following limits. If I replace x by 0, e to the power 0 is 1. 1 minus 1 is 0 plus 0. So I'll have 0 over 0. So I can use L'Hopital's rule. Derivative of 1 is 0. Derivative of ex is ex. Derivative of x is 1. Derivative of x squared is 2x. If I replace x by 0, e to the power 0 is 1. Negative 1 plus 1 is 0 over 0 again. So I use the L'Hopital's rule again. Derivative of negative ex is negative ex. Derivative of 1 is 0 over derivative of 2x is 2. Replace x by 0. E to the power 0 is 1. So the answer is negative half. Here, if I replace x by 0, tan 0 is 0. 1 over 0 plus is infinity. So I have 1 to the power infinity. This is an indeterminate form in which we solve by writing y equals 1 plus tan x to the power 1 over x. And then we apply len to both sides. So len y would be len of 1 plus tan x to the power 1 over x. And then I can bring 1 over x here using the properties of len. So len y would be equal to 1 over x times len 1 plus tan x. And now I find limit y, len y, limit len y, when x goes to 0 plus. And len y is 1 over x. I will write it len 1 plus tan x over x. You can just write 1 over x times len. You can write it len over x. Okay. If you replace x by 0, tan 0 is 0, len 1 is 0, so I'll have 0 over 0. So I can use L'Hopital's rule. Find the derivative. Derivative of x is 1. So find the derivative of the numerator. Derivative of len is 1 over 1 plus tan x. Derivative of 1 plus tan x. Derivative of 1 is 0. Derivative of tan x is secant square x. And now if I replace x by 0, secant 0 is 1. Tan 0 is 1. So I have 1 over 1, which is 1. So limit len y is 1. So limit when len y, if len y goes to 1, then e to the power len y will go to e. So y will go to e, and limit y, which is 1 plus tan x to the power 1 over x, when x approaches 0 from the right, would be e. So this limit is equal to e, and that's the answer. This is a function, g of x. Find the intervals on which g is increasing or decreasing. We need to find the first derivative for that. So g prime of x is equal to, this is product. We use the product rule to find the derivative. Derivative of x is 1 times the derivative of e to the power 2x plus x times the derivative of e to the power 2x is e to the power 2x times the derivative of 2x, which is 2. And now we need to find the critical numbers. To find the critical numbers, we put the derivative equals to 0, and we try to find the zeros of the derivative. I can take e to the power 2x as a common factor. I'll have 1 plus 2x equals to 0. Now e to the power 2x cannot equal to 0. It's not possible. So 1 plus 2x could be equal to 0. So that's the only possibility. So 2x equals negative 1, and x is negative half. So this is the critical number. The only critical number of this function is negative half. Now, to find the intervals of increasing and decreasing, I need to find the signs of f or g prime here. The function is g prime. When g prime is positive, the function g would be increasing, and when g prime is negative, the function g would be decreasing. So negative half, choose a number to the left of negative, to the right of negative half, 0, for example. 0 is greater than negative half. The domain of this function is also all real numbers. I don't have any problem with it. E to the power x, domain of E, all real numbers. So here I have from negative infinity to infinity. 0, put 0 here in g prime. If you put 0 here, okay, you find e to the power 0, which is 1, so it's positive. If you choose a number less than negative half, negative 10, for example, this would be negative, plus this is a very small positive number, so you will have a negative number. So here the function is decreasing, here the function is increasing. So decreasing intervals where the function is decreasing would be from negative infinity to negative half, and increasing from half to infinity. So this is the answer of this part. Now the second part, part B, find the local maximum and minimum values of G. You can see here that f of negative half is a local minimum. And we don't have a local maximum, okay? The local minimum is f of negative half. Find limit of g of x, this function, the same function, when x goes to negative infinity. So let us see what happens. The function is x times e to the power 2x. If I replace x by negative infinity, I'll have negative infinity times e to the power negative infinity is 0. So I have negative infinity times 0. So this is an indeterminate form, and we have to write one of the functions down. If you write x down below as 1 over x, and you find the derivative, you use the L'Hopital's rule, you will find that the resulting function is even more difficult than this one. So the correct way is to take e to the power 2x down and write it e to the power negative 2x. Now I'll have negative infinity up, and here negative infinity, infinity e to the power infinity is infinity. So now I can use L'Hopital's rule, and I find the derivative of x, which is 1. Derivative of this one is negative 2 times e to the power negative 2x. Now e to the power infinity is infinity times negative 2, so I'll have 1 over negative infinity, and 1 over negative infinity is just 0. So that's the limit of this function. The next question, this is a function f, find the domain of f. Well, this is a square root, so 1 minus x squared has to be greater than or equal to 0. And to test the signs of this side, 1 minus x squared, I find the zeros, and the zeros are negative 1 and 1. So I can find the signs easily of this, of 1 minus x squared. If I replace x by 0, for example, 1 minus 0 is 0, so here it's positive, while 2 will make it negative, negative 2 will make it 1 minus 4 negative. So I need it to be positive, so that's the answer. So the domain of this function is from negative 1 to 1. That's the domain of the function. Find all critical numbers of f. To find the critical numbers, I need to find the derivative. The derivative of this function, this is a square root, so the derivative is 1 over 2 times the square root times the derivative of 1 minus x squared, which is negative 2x. Can cancel 2 with 2, and this would be the derivative. Now to find the critical numbers, either the derivative is 0 or the derivative is does not exist. The derivative would be 0 when x is 0, when the numerator is 0. The derivative would be does not exist when 1 minus x squared equals to 0, when the numerator equals to 0. So when x is plus or minus 1, okay? And all of these numbers belong to the domain. So plus or minus 1 belongs to the domain of f, 0 belongs to the domain of f. So critical numbers are 0, 1, and -1. This would be the answer of this part. Question 5. This is f of x function, x over x cubed minus x. Determine whether f is even or odd or neither. To determine that, we find f of negative x. We replace x by negative x. We replace x by negative x. So I'll have negative x over negative x cubed minus times minus would be plus x. Now, if you look carefully to this function and compare it to f of x, you notice that if you multiply, this is f of x. Whenever you have a over b, you can say it is equal to negative a over negative b, because you can cancel minus with minus. So here, if you multiply the numerator by negative, you will have x. If you multiply the denominator by negative, you will have x cubed minus x. So this is in fact f of x. So the function in fact is even. So please pay attention. Half equals to -1 over -2. You can multiply the numerator by -1, the denominator by -1 without any problem, okay? So f of negative x equals f of x here. Notice that negative f of x here is negative x over x cubed minus x. You multiply only the numerator, or you multiply only the denominator by negative, okay? So this is negative f of x. And it is not equal to this one. It is not equal to f of negative x, okay? Because here I have negative x, the denominator is different, all right? And here the numerator is different. So I hope you understand this point. It's very easy. Whenever you have a over b, you can write it negative a over negative b. So f is even. Give the equations of the horizontal asymptotes. To find the horizontal asymptotes, we need to find the limit of the function, which is x over x cubed minus x when x approaches positive or negative infinity. There is no difference here between positive or negative infinity, because in fact, how to find the limit, you can use L'Hopital's rule if you like, because you have infinity over infinity, or you can just take the highest power in the numerator, the highest power in the denominator. So this would be the derivative of the limit of 1 over x squared, and 1 over infinity or 1 over negative infinity is 0. So the horizontal asymptote has the equation y equals to 0. So y equals to 0 is a horizontal asymptote of this function. Equations of the vertical asymptote. In fact, f of x is x over x cubed minus x. And if you take x as a common factor from the denominator, you will have x squared minus 1. So you can cancel x with x, and you will have 1 over x squared minus 1. So x squared minus 1, the zeros of the denominator would be 1 or -1. So the vertical asymptotes are x equals 1 and x equals -1 and there are two vertical asymptotes. Notice that at x equals to 0, there is a hole and not vertical asymptotes, because 0 will make the numerator 0 and the denominator 0. If you replace x by 0, you will have 0 over 0 in the function. But 1 will make 1 and -1 will make the denominator 0 and the numerator not 0. And that's the definition of the vertical asymptotes. So please pay attention to this point. Find the point on the line. This is a new question. There is a line to x minus 4. Let me sketch the graph of this line. When x is 0, y is -4. And if y is 0, 2x equals 4, x equals 2. So that's the line. Okay, that's the line. And the point 0, 1. Okay. So we need to find the point on the line that's closest to the point 0, 1. For example, this point, xy. So we need to minimize the distance between the point 0, 1 and the point xy. The distance is given by x minus 0 squared, y minus 1 squared. This is the formula for the distance, y minus 1 squared. And we can deal with the square root. You can deal with the square root if you like. And you can change the question to minimize f, which is d square, without square root now, because you are raising to the power 2. And I'll have x squared plus y minus 1 squared. And the minimum of d is the same as minimum, the minimum of f. Okay. Now, to find the minimum, I have f. I have to write this in one variable. So I have to replace x or y, y to x or x to y, using this definition. So f is equal to x squared plus, now y is 2x minus 4, and there is a minus 1. So I have x squared plus 2x minus 5 to the power 2. Now I find f prime. To find the minimum, we find the critical numbers. The derivative is 2x, and here the derivative is 2 times 2x minus 5 times the derivative of 2x minus 5, which is 2. So f prime is in fact 2x plus 2 times 2 is 4 times 2x is 8, and 2 times 2 is 4 minus 5, -20. So f prime is 10x minus 20. You put it equals to 0. So x would be 20 over 2 or 2. So this is the critical number of this function. Now, if I find f double prime, it would be 10. And it's greater than 0. So I have a minimum here, a local minimum, and it would be an absolute minimum because it is one minimum in this interval. So what is the question? Find the point on the line that's closest to the point 0, 1. So when x is 2, the point would be closest. So how to find y? Y is 2x, so 2 times 2 minus 4. 4 minus 4 is 0. So the point is 2 and 0, which is this point. 2, 0 is the closest to the point 0, 1. You can prove that this is minimum either from the second derivative test, or you can find the signs of f prime. Suppose a circle is increasing at a rate of 5 centimeters per minute. At what rate? Here, in fact, the question is, suppose a radius, the radius of the circle. Suppose that the radius of the circle is increasing at a rate of 5 centimeters per minute. So if we call the radius r, then dr by dt is 5 centimeters per minute. At what rate the area of the circle is increasing? So dA by dt, what is dA by dt? When the radius is 200 centimeters. Related rates, we need a relation between the area of the circle and the radius of the circle, and we know that the area of the circle is pi r square. So when we find the derivative with respect to time, pi is a constant, so the derivative is 2 pi r dr by dt. So dA by dt would be 2 pi times r, which is 200, and dr by dt is 5. So we will have 10 times 200, that's 2000 pi centimeter square per minute. This would be the rate of change of the area. Find the equation of the tangent line to this curve at x equals 1. Well, the equation of the tangent line is y minus f of 1, okay, because x is 1, equals f prime at 1, that's the slope, times x minus 1. So f of 1, I replace x by 1, then 1 is 0. So f of 1 is 0. To find f prime of 1, I find f prime of x. Derivative, this is a quotient rule. I have to use the quotient rule. Here, x squared. Derivative of ln x is 1 over x times the denominator, which is x, minus derivative of x is 1 times ln x. X times 1 over x is 1, so the derivative is 1 minus ln x over x squared. And f prime of 1 would be 1 minus ln 1, which is 0, over 1 square. So f prime of 1 is 1. And the equation is y minus f of 1, 0. F prime of 1 is 1 times x minus 1, or just y equals x minus 1. State the numbers at which f is not continuous. Well, f is not continuous when x is 1. Here, at this number 1, the function is not continuous. State the numbers at which f is not differentiable. F is not differentiable at -2 because there is a corner, and it's not differentiable at 1 because the function is not continuous, and it's not differentiable at 3 because at 3 there is another corner. Calculate here the derivative. Okay, so this is y prime, derivative of sine inverse is 1 over square root of 1 minus u square. So I raise this to the power 2 times the derivative of this, which is 6x squared. So the answer is 6x squared over 1 minus 4x to the power 6. 3 times 2 is 6. That's the derivative. Here I use the product rule. Derivative of cosh is sinh times 3 because of the 3x times tan square root of x plus cosh 3x times the derivative of tan. Derivative of tan is secant square times the derivative of square root of x, which is 1 over 2 square root of x. So that's the derivative. Here, this is implicit differentiation. Y times sine, this is product. So derivative of y is y prime. Derivative of sine is cosine. E to the power xy, derivative is the same, times derivative of x times y. Derivative of x times y is product. Derivative of x is 1 times y plus x times derivative of y is y prime equals derivative of y squared is 2y times y prime. So now I have y prime. I can take it as a common factor. And here sine x remains. And here I have x times exy and minus 2y when I bring this to the other side. And then I have only y times cosine. When I take it to the other side, I can write it like this. And also I have negative y times exy. So y prime would be, I divide by the coefficient of y prime. So this is y prime. Now here I have a function raised to a function. So I have to use the len. And then I can bring x here. And now I find the derivative. Derivative of len y is y prime over y. And this is product. Derivative of x is 1. Derivative of len sine is 1 over sine times derivative of sine, which is cosine. So the final answer, y prime, would be len sine x plus x. Cosine over sine is just cotan times y, which is sine x to the power x. The last question, sketch the graph of a function that satisfies all of the following conditions. I have some information about f prime, the signs of f prime. So in fact, I can make a table of signs for f prime here. So from negative infinity to 0, 0 to 3, 3 to infinity. So this is 0, this is 3. So when f prime, from negative infinity to 0, f prime is positive. From 0 to 3, f prime is negative. From 3 to infinity, f prime is negative. Okay. So I can get from here that f is increasing, decreasing, and decreasing. And I can find out that f of 0 is local maximum. And f of 0 is given here. F of 0 is 2. So f of 0 equals 2 is local maximum. For f double prime, I have f double prime less than 0 from negative infinity to 3 and from 3 to infinity. So 3 is the most important or the number in which f prime changes its sign. So f double prime is negative from negative infinity to 3, and it is positive from 3 to infinity. So f here is concave down, and here f is concave up, and I have an inflection point at 3 But he said the domain all real numbers except 3. Okay, so 3 is not in the domain, and x equals to 3 is a vertical asymptote. Okay, I can sketch the graph now. One, two, three. This is a vertical asymptote. F of 0 is 2, and this is a local maximum. What else? Limit f of x when x approaches 0, when x approaches infinity is 0. So this line is a horizontal asymptote. So this is a vertical, this is a horizontal. So the graph would be like this, and the function would be increasing to the left of 3 and concave up after 3. So this graph is perfect. While here to the left of 3, this is the local maximum, and the function from negative infinity to 3 is concave down. That's good. So it's just concave down, and it's increasing up to 0. So it's increasing up to here and increasing here. So that's the graph of this function, or this is a possible graph of the function. It satisfies all the conditions. From negative infinity to 3, concave down. From 3 to infinity, concave up. From negative infinity to 0, it's increasing, decreasing from 0 to 3, and from 3 to infinity. F of 0 is 2. Y equals to 0 is a horizontal asymptote. X equals to 3 is a vertical asymptote. Thank you very much. I hope you enjoyed listening to these solutions.